Yeah.
Did you all come?
virtual folks. Good morning, I'm Wendy Harper, and the session today is the rehabilitation of the John A. Roebling Bridge over between Cincinnati and Covington. The first speaker is going to be Craig Klusman. He's the structural engineering manager for AECOM in the removal office, and I'm going to let him introduce the rest of the team.
Thanks, Wendy. So this is the Roebling Bridge Rehabilitation presentation. Sorry about this. It was working before.
Anything?
Oh, food would be great.
What?
Food would be great.
Food. Right.
Oh.
Or, microphone. All right, thanks. Does everybody hear me? All right, good deal. So I'm Craig Klusman with AECOM. I'm going to introduce the team real quick, and then we'll get into the presentation. Over on the left is Nick Rice. He's on the owner's side with the Executive Transportation Cabinet. He's the District 6 bridge engineer. Alan Cantrell is a bridge engineer with AECOM. And over to my right with THP, Tony Mette and Mitchell Holker. We brought THP on the team for their masonry expertise. They do a lot of building facade restoration, and they're based out of Cincinnati, Ohio. Just at the project site, basically, just right down on Bond Street.
Oh, 6 blocks away.
He was the splitter woman? No. Okay. Roebling Bridge, iconic historic structure connecting Covington, Kentucky and Cincinnati, Ohio. It's bridge was built in 1865. It's really a neat bridge designed by John A. Roebling. You don't get the appreciation of how, I guess, how important it is for the community up there. But when you work on the bridge, you got a lot of people walking by and taking pictures and selfies and whatnot. So the city of Cincinnati definitely takes a lot of pride in Covington too. Takes a lot of pride in this structure. So it's definitely an honor to be able to work on it. So a little agenda, I'll go over this quickly. Nick's going to kick it off with a little project background. Alan's going to talk about the inspection masonry survey. Tony and I are going to talk about the anchors 2 waterproofing. And then Tony and Mitchell will go over the tire waterproofing. And then we'll wrap it up with talking about a couple miscellaneous repairs and progress of construction. With that, Nick.
Good afternoon. I'm going to give you, for those of you who aren't familiar with the bridge, I'm going to give you a brief overview of the history of the bridge and some of the previous repairs that have been made to maintain this historic structure. After some delays due to the Civil War, the original construction was completed in 1867 for a total of $1.8 million, which included the lower cast iron cables and stone towers. The first major reconstruction was in 1892 for a cost of $600,000, which included additional steel cables and a new, stronger stiffening truss to support the heavier loads going across the bridge. The state of Kentucky purchased the privately owned bridge in in 1953 for a cost of $5 million. At that time, it performed the second major reconstruction that removed the old timber deck and replaced it with a steel deck. They added stairs and reworked the Ohio approaches to better connect to the road network on the Cincinnati side. The third major reconstruction occurred in the 1990s for a cost of $10 million. This historic restoration completely removed the old steel or the old silver tower houses, and that was installed in the 1890s reconstruction, and replaced them with the Greek ball and cross. As you can see in the photo, they did it with helicopters. That was what the original tower houses looked like in 1867. The stairs were also rebuilt, aesthetic lighting was added, and there was some repairs to the stone and steel deck at that time. Additional structural steel deck repairs and roadway lighting were worked over in 2006 for a cost of $3.1 million. And in 2010, the entire steel superstructure was cleaned and painted for a cost of $16.2 million. Recently, in the winter of 2018, a vehicle struck and bent one of the compression members of the steel truss. The bridge was closed for emergency repairs. For $62,000, the contractor was able to each straighten the vertical and replace the back plates at that location, which allowed us to reopen the bridge to traffic. Shortly after reopening, the structure was due for a thorough crash critical inspection, which Alan will kind of dig into.
It's Nick said, KYPC contracted with AECOM in 2018 to conduct the fracture critical inspection. And alongside that, we also conducted a masonry survey of the towers and anchorages. We were able to complete this work with rope access methods, a man lift, and some structure climbing. During the masonry survey, we used a crew of 4 rope access technicians. It took about 7 days to do the top 25 feet of both towers as well as the anchorage. During this process, we were able to use partial roadway closures and sidewalk closures just to facilitate the safe zone around the inspectors. We're also tasked with developing efficiency quantities as well as repair quantities and detailed drawings to give to KYTC in preparation for this repair. Types of repairs included composite patching, Dutchman's, and masonry crack injections, and tuck pointing all grout lines. Since it is a historic structure, we didn't really have many as-built to go off of, so we did some exploratory excavations above anchorage 2. And included removing some pavement above the anchorage, as well as drilling into the sidewalls in an effort to see how thick the stones were and what the subgrade material consisted of. Shortly after our masonry surveys and pressure critical inspection, there were some stones that fell into the roadway, which prompted KYTC to install the emergency netting that was around both towers for about a little over a year, I believe. And also prompted the scope of this bridge restoration, which included the restoration of deteriorated masonry, waterproofing the roof of the tower, or the tower roof, waterproofing anchorage 2, and some miscellaneous repairs, including zipper boots, suspender collar replacement, bearing, anchor bolt retrofit, and a steel deck repair. So AECOM and THB developed these repair plans, and the project was let on September 25th, 2020 to Lithco Restoration Technologies, or LRT, for a little over $4.7 million. And we had held the pre-construction meeting on January 8th, 2021. The contractor was limited to staging their equipment and materials below the bridge on the north and south ends of the bridge. The roadway closures were a complete vehicular roadway closure, and then one sidewalk was left open for pedestrian traffic for the entire duration of the project. We also did not disturb the park in the near area on the north side. We did have to remove a bathroom facility that was underneath. But the Materials were stored on the north and south ends of the bridge, just so they were easily accessed during the repair process. We'll hand it over to Craig to discuss the repair design for the anchorage in the tower. So the project is primarily a masonry restoration project. You know, there were a few other miscellaneous repairs, but the purpose of the project was really to restore some of the deteriorated masonry, and specifically the scope of the project was the upper 25 feet of the north and south towers, which are the smaller circles there in the screen, and also Anchorage 2, which is over on the Ohio end of the bridge. Here's a photograph of Anchorage 2, showing both the view down at Snail Waterfront Park in downtown Cincinnati, and then the roadway view of Anchorage 2 as well. Underneath the anchorage there, you can see on the left photograph, it's kind of neat. They've got some lighting down there to kind of light it up. And I heard before that they were doing some event. They wanted to use that space down there in that archway for events like wedding receptions or maybe other kind of events. The problem is with the water infiltration coming through the arch, there's some leakage down there, as well as some spalling and delaminated stones. As you can see in this photograph here on the left, some of the water pooling at the bottom, and some of the previous patches were done or not done properly. Doesn't look very nice and whatnot. So I'll talk a little bit about the design of the kind of what we're aiming for over there. Tony's going to go through and discuss some of the construction, looking down the construction. So the concept here was to go ahead and remove all the fill above the arch, as you can see in the left photo there. And then what we want to do is we put it back to put a concrete arch slab in. That had really two purposes. One is we want to support all the stones in the cross section there, in case any got dislodged during construction or had some deterioration. We would provide support to those stones. After that, we would put a waterproofing membrane on top of that arch slab with some drainage blankets, and then do a structural granule backfill, free grade backfill, and then top it off with a concrete roadway slab. If you see the blue is concrete there, and the orangey yellow color structural granular backfill, and this is a section view across along the whole arch. You see a similar how it was done with the arch concrete. We use introduced keystone anchors to secure the keystones, and then extra anchor space at 18 inches. Also want to point out in this view here, the purpose of the anchorage is obviously to, the primary cable comes into the anchorage and turns down and it's bedded underground. So we looked at originally, we had this concept and we thought, well, wait a minute, we should probably look and make sure that we're not unloading the arch too much as far as taking that dead load off. There's of course no design plans for the Roebling Bridge. There's no drawings of the anchorage, anything like that. So everything's we basically did was just a kind of a quick engineering calculation to see how much load we're removing based on the overall load, and decided it was probably prudent to do this in two phases, to have them remove about half the fill, put back the fill, and then do the other side. We also restricted, of course, the bridge obviously has to be closed during this. We also restricted the contractor from having any live load, substantial live load. They get a pickup truck or something out there, but no substantial live load on the suspended stands during this process. We also, during construction, because when we unload the arch with the weight on top, you're going to take some of the compression out of the arch ring. So we required the contractor to temporarily support all the stones across the cross section there. So it was quite the system they developed. They used these jacks, and then had some, you can see the photograph over on the right, they had some plywood forms basically went across the entire cross section. It's kind of neat, and it's done well. I'll pass it over to Tony now to talk about what they found during the excavation.
So as Craig said, there was no available drawings when we started this. So when they started digging down, we didn't know what they were going to get into. And one of the key was purpose of that was re-waterproofing the archway. So as they dug down to about 6 feet on the right photo, you can kind of see the roughened edge, kind of in that backfill. It was wood timber found that back then they soaked in the creosote and kind of, that was their attempt to waterproof the top side of the arch. Is once we dug down into that photo on the right-hand side there. It's just kind of interesting that we didn't see a way to get the water out once it was down there. So there was no visible way to discharge it at that level of the arch as we dug down to that surface. And it kind of, there's some history on it, I guess, but it was the Philadelphia and Reading Railroad in the early 1800s started to do this same creosote system on all their timbers for their railroad systems. Here's kind of photos of the work in progress. As Craig mentioned, the photo on the left is the south first phase, and they're excavating pretty much down to the top surface of the archway sandstone. The photo on the right is the first phase completed on the south side, then working to the north excavation. You can kind of see in that photo, the concrete archway slab is kind of right at the base of the ladder there that extends out from the dead men that are sitting on it, hold back to backfill, and the waterproofing extends out about 2 feet for them to lap in with the second phase. You can kind of see the anchor rods that have been drilled into the archway stones in that photo in preparation for pouring that next section of slab. More photos here. Photo on the left is the south face concrete archway poured into place. You have the cast in place end wall. Kind of interesting. I think it shows up a lot better in the right photo. The condition of the stone is in great condition below the roadway. You can kind of see that on the right hand side. You can kind of see some of the deterioration of the stone, kind of where about the roadway surface would be. But once we got into that backfill, there was not much deterioration of sandstone there. Right hand photo shows the completed waterproofing system. That's the protection board that's on the hot apply fabric reinforced waterproofing system there, 215 mil system. We set up with the contractor. They did a leak detection system in the process after that was completed. They used kind of electric field vector mapping where they saturated that surface in water and took a probe and confirmed there was no leaks or there was any grounds to the surface below. So once that was done, they started backfilling in the photo you saw on the previous page. And kind of the main thing upcoming work is, as Craig mentions, the photo here on the left is, you can see all the leaks. So the second phase of the slab was poured last week. They plan to start removing the shoring here, hopefully later this week, next week when it reaches strength. Then they'll start the process of doing the stone restoration down there while finishing up the waterproofing and the backfilling in the north phase of the Anchorage house.
So I'm going to touch on some of the unique work that the contractors have done to prepare for their masonry repairs. The bridge tower's height and geometry required some pretty unique swing stage rigging to complete these repairs. Some included operable chains that were attached to the outrigger beams at the very top of the swing stage assembly that the contractor would use to adjust and get them closer to the repairs as needed while they're up in midair. Also, they also had some adjustable chairs that were hooked onto the swing stages that they would swing in and out to get hard to reach corners up in the towers. The photo on the left that you'll see is a set of stairs that are on both towers that are on the west elevations that are used to access the roof. What you'll also see is that an additional rail has been added on top of the original 2 rails for safety. Originally, those 2 rails were just there and they come up right to your hips, so it's a little scary walking up and down those stairs. I personally prefer the swing stages over the stairs any day. And the right photo you'll see is on the roof of the towers where they have all the swing stages staged and all the rigging equipment located. It became a pretty complex and hard to navigate at times, especially to review repairs up on the roof, as well as survey the equipment before we rode the stages.
So we're gonna get into kind of the restoration of the tower at this point, the masonry and that. When we got up there, as you can see in these photos, a lot of the mortar joints were cracked, deteriorated, and beginning to fall out. The right-hand photo shows kind of some of the past repairs. Edges of the sandstone kind of eroded away, so they would just take the mortar and smeared it over the sandstone. You can kind of see the width. And I guess the biggest bottom left photo or stone in that photo of the mortar kind of smeared over the surface. So as we started, we're trying to figure out the best way to attack this. And kind of similar to that, some of the past repairs, the mortar that was used did not kind of follow what we use for sandstone and historically what was done. A lot of the mortar was cement based, very hard mortar. So you can see kind of as that sandstone eroded from weathering over the years, it's created a nice channel for water to flow back behind the mortar joints. And that was an issue we saw just kind of as we started to survey the bridge, the best way to attack that. So in the end, the decision, we're repointing the entire upper 25 feet, this phase of work of both towers and where we're working on anchor chest 2. You can kind of see the joints being cut out here and then being reinstalled on the right-hand side photo. Some of the things that to kind of talk about in the repointing process, while doing the design, we did take samples for petrographic analysis to come up with the consistency of the mortar. That was a challenge initially, is retrieving samples that was historical mortar, because most of everything we're getting was the outside had been redone at some point. So 2 samples were taken. One sample was more reflective of a type N mortar. It had about 1 part cement, 1 part lime, and about 6 parts aggregate. The second sample, just on pure mixing, was closer to a type S than a type N mortar, more of a structural mortar, with less lime and sand in that sample. But both mortars during the both samples during the testing, they were able to confirm it historically that it was a natural cement and dolomitic hydrated lime in both samples to kind of confirm the age that was original mortar to the bridge. The contractor is kind of approved manufacturers that were put into the specifications, went ahead and worked with U.S. Heritage Group to provide their masonry products. In the process, we went through reviewing their options. It was an NHL 3.5 mortar mix that was selected. The NHL is the European standard. So it is very similar to a type N with a lime-based mix that meets the design intent of the National Park Service.
So as Alan had mentioned, and Craig had mentioned, there was an original survey on the bridge towers and the masonry that identified pretty typical deteriorations that we were seeing all on the bridge elevations, including cracking, shaling of all the stone surfaces, as well as spalling. The most severe deterioration that you'll see here in these photos was on the northeast corner of both towers. We attributed this deterioration to poor drainage design on the roof that was directing water right at this corner that was causing severe freeze-thaw action to occur over a long period of time. The photo on the left is another photo of this area, and you'll see severe spalling, as well as, if you look closely, you can see exposed cracks from the spalled surface that are soaking up moisture and exposed to weathering that would eventually just cause further deterioration and freeze-thaw action in this exposed sandstone. That would be a severe hazard to people below. And similar to what Tony had mentioned about the mortar, what we were also finding along the facade of the towers was that there were previous cementitious patches performed at deteriorated stone. And it was causing a similar issue. One, at every patch that we had found, it wasn't really bonded to the existing sandstone surface, as well as it was due to the hardness of the cementitious material. It was causing more damage than good to the existing sandstone and causing more spalls and deteriorations in the existing sandstone. So from this initial survey, as Alan kind of alluded to, we were able to categorize all these different repairs, as well as. Can you hear me? Okay. As well as provide a pretty accurate estimate for what we were anticipating for the amount of repairs we were going to see once Litco got on site and started performing masonry patches. So the patches again were identified from a visual and sounding survey, and as the deteriorated stone was removed, either AECOM or THP would go up on the swing stages and re-review these patches to confirm whether they were going to be a composite patch or a Dutchman, depending on the severity of the deterioration that we were seeing. And early on, prior to a mock-up, three different types of colors of patch material were selected to match the existing sandstone color as close as possible. And during an initial review by the contractor, they would go up and mark each different repair with different colored chalk to identify the type of repair, as well as the combination of colors of patches to match the existing patch. The patches themselves were installed outboard of the existing sandstone in several lifts. The final lift would then be scored or carved to get the striated pattern to match that you'll see on the right with a few patches shown there. And then finally about the patches on the south and west elevations, something that AECOM and THP ourselves that we identified was some cracking that we saw in completed patches that we identified to be the result of the patch material curing or drying too quickly. So we've since worked with the contractor to refine that process for using damping misters to just continue to keep that surface wet. So as I mentioned, the extent of the severity of the existing stone was going to indicate whether it was going to be a Dutchman repair or a composite patch material. For the Dutchman repairs, the new stone was selected from the Waller Brothers Stone Company, which was actually the original quarry that was used to construct the bridge towers. The Dutchman repairs typically consist of a 4-inch thick piece of new stone that was anchored to the existing stone with stainless steel pins that are epoxied into the stone surface at 8 inches on center. And then if you'll see on the photo on the right, there's a cavity between the existing and the new stone that was eventually grout filled with a flowable grout material. These photos specifically were taken from the South End Bridge where the contractor set up the mock-up. So to kind of backtrack, this is the northeast corner where we had mentioned this severe deterioration was observed in the original survey. And these photos illustrate the challenging Dutchman repairs that we were requiring to be installed. The work actually exceeded the anticipated amount of removal that was needed to acquire the proper bearing depth for the stone, which prompted us to require some additional removal of the stone, as well as installing the new Dutchman pieces kind of sequentially in 30-inch horizontal sections. And prior to any additional removal and installation, we had Litco drill some test holes to confirm the depth of the stone was adequate.
And as Mitchell was discussing before, the key is kind of maintaining the waterproofing or trying to re-waterproof the top of these towers. So this is during the survey. On the right-hand side previously, they went ahead and put a kind of concrete fill slab on top of it for drainage on top of the towers. And they created a trough along there to collect the water diverted off the side of the tower. So when doing the repairs, we're improving drainage on the towers. We're looking at installing kind of a stainless steel angle to increase the capacity of this trough and help divert water away from rolling over the edge, is how we're kind of trying to improve the whole system here. So overall, the concrete cap is in good shape up there now. It was previously coated with an epoxy system that UV has degraded it after 30 plus years. The problem is, and this is to Mitchell's point, at some of like the corners of those towers, the cap stopped, and the waterproofing that was there no longer exists. So any water that's getting up there now is infiltrating those joints and getting behind the stone. So we're going back with a new coating system on top of the tower that will be from edge to edge of the tower to address this issue, which is a urethane-based coating system. Included with the top of the tower is restoration of the perimeter rail. The issue we were seeing, the kind of U-pins between the top stones and the horizontal rail were the original steel pins that over time they kept corroding and continued to crack the stone. So all those that were being cut out, you can kind of in the background to the left picture, you can kind of see the top edge of one of those stones completely cracked away on that face. So all that's being rebuilt with new stone, new stainless steel pins. And we're going back, retuck pointing the entire rail and kind of finishing off the joints with silicone sealant on the top perimeter, just from long-term protection. And throughout the rail, there's replacement of posts throughout where full sandstone posts were being replaced as that rail is being restored as we speak.
Touching on one of the miscellaneous repairs that kind of goes into the masonry as well, at each of the tower penetrate, or the cable penetrations in the towers, they used to have metal bolted boots that were bolted to the outside of the masonry. A lot of them were either missing or damaged, as you can see on the right. This is allowing windblown water into the top of the towers as well as into the cable groups that were not protected by the wire rack. So we're going back with a rubberized 3/8 inch to 1/2 inch thick boot, or with a corrosion resistant zipper. This will both be for the primary and secondary cables going into all tower penetrations. And what this allows is a watertight seal at each of those locations. So it'll be, I think, about approximately 12 to 15 feet long. So you should have a pretty good watertight seal on each penetration. I'll hand it over to Nick to discuss a construction update.
As for the current construction, the contractor is due to be switching the sidewalk closure this week or next. At that time, they will finish up the root stone repairs at the top 25 feet of the towers. They will also continue working on repairing the arch and removing the supports. Then they'll start waterproofing the top of the tower once the rating is removed. They're due to be completing this restoration work late this fall, early winter. On the top 25 feet of the towers and anchors too. We will continue to work hard towards the preservation of this historic structure, with likely more projects to come. Are there any questions?
Any questions for us? Quiet group.
I'll give you one.
Just listened to Amanda talk about the history of KYTC, and she mentioned the bridge, the Roebling Bridge. She quoted, I think, a different price as to what the state purchased the bridge. And I didn't know if it might be a difference in years, dollars, if it was 19, in the original day dollars, or if it was in some sort of contemporary measure.
Nick, do you know the answer to that?
I'm not sure. I had to go look into it, see exactly if the number I had was adjusted or not.
Yeah, just a neat bridge, just a marvel of construction. It was designed in 1856. Did you all say that?
1865, I know is I believe the year of opening. It's the year that's etched on the towers.
Okay.
I believe
Yeah, it was
the
actually designed before the Civil War, and Civil War.
Yeah, it started earlier than that.
Yeah.
Construction was completed by 1867 when it was opened,
Yeah.
but it started and there were delays due to the Civil War.
Yeah, and she said in 1953, it was first. So the difference in dates, and I don't know, both of you all, the work that y'all did to the bridge is pretty phenomenal. Yeah, 160, almost 160 years old. We still got traffic on it.
Yeah. And we certainly took some time in developing, a lot of special notes and provisions to make sure the masonry repairs are, what we wanted to keep the bridge historic and from a historical standpoint too, working with the SHPO and whatnot to get the environmental approvals. So, yes.
What's the current weight limit on the restoration stuff?
Well, we won't increase it, it's currently 11 tons, and it'll maintain.
How long has it been there?
Do not know the answer to that.
I believe it was around 2000, they did a load rating on it, due to section loss and some of the floor beams not controlling.
So it's never been 80,000.
No,
Not as far as I know, no.
but we're not doing, none of the repairs we're doing are actually increasing the structural carrying capacity of the bridge. I'd say, a little more maintenance type restoration, keeping water out and repairs than actual strengthening the bridge.
Was any of this work taking place when the Rets fence was closed?
Yeah,
No, not, and then it was actually closed, but the bridge is worth noting, the branch patch is down 2 lanes right now due to a paint project. But the Roebling is also shut down, which is probably a good thing because tractor trailers tend to like to use the bridge overloaded, could potentially damage the structure.
During the bridge fire, we actually closed the bridge for that very reason, so you detour traffic couldn't use the bridge. And the other one note I don't think we brought up was, we got sidewalk open, which is something we would never do with the locals, but the sidewalk, this is a highly traveled pedestrian access as well, more so than vehicular traffic, so we have to work around that while we're working on this bridge to keep at least one sidewalk open, because we're working, under people are walking under.
right. And the contractors installed some scaffolding, protection for pedestrians walking on the tower, though they're not working directly above the open sidewalk, but they did provide some protection down there in case the piece of loose masonry got fell down there in their area. Well, thank you all. Wendy, do you have anything else to?
No, I'll just say a reminder to that the session evaluations are on the app this year. Fill those up.